discuss about PLC and IIoT, the difference and the similarity. So we have already discussed a few points about the PLC in our previous videos, and also we have learned a few programming and applications about PLC. However, PLC is a programmable logic controller which is meant for the industrial controls and industrial automations, and the newer technology is IIoT, that is Industrial Internet of Things, also meant for industrial automation, but it has different capabilities compared to PLC. We are going to understand the difference between the PLC and IIoT in terms of capabilities and in terms of advantages and drawbacks. And let us start now with the introduction. I am going to discuss about what is PLC, what is IIoT in the introduction part, and after that I am going to give a detailed comparison between these two, and then we are going to understand how PLC and IIoT are making the industrial automation to the next level, and comparing PLC IIoT benefits and limitations. And at last we are going to discuss about the future of industrial automation, that is integration of PLC and IIoT, so which is a very important thing. Let us start with introduction. So programmable logic controllers and the industrial Internet of Things are two distinct technologies that play important role in industrial automation. Of course, we know these PLCs are used in industries from almost 1960s to achieve the industrial automation. Either it is a smaller machines or the complicated machines or the complicated setup. So the industrial Internet of Things are the recent technology or the new technology which is also being used in industrial automation. We are going to understand how and what is the difference between these two technologies and how it helps each other and how it is going to be integrated in future, so that we are going to get a better results. What is PLC? A programmable logic controller is a small modular solid state computer with customized instruction for performing a particular task. PLC used in various industrial control systems have primarily replaced mechanical relays, drum sequencers and cam timers. As I told you little earlier, programmable logic controllers are a microcomputers which is capable of handling the inputs and outputs which is coming from the field devices. Based on the instructions written in the program, it is going to control the field device and it is going to achieve the automations. And these PLCs are used for achieving many industrial process control and automations. And the objective of bringing this PLC to the industry is that to replace the mechanical relays which was used earlier days for achieving the automation. So these mechanical relays are well and good enough to achieve the automation for a smaller logics. Say for example, if you have two limit switches and you want to move the cylinder forward and return automatically once the push button is pressed. So by having two limit switches in the home position and the extended position of the cylinder, and which is going to be controlled connected to the relays, so based on that the relays can drive the solenoids and the solenoids can actuate the valve so that the cylinder can move forward and return. So this is a simple automation which is very much easily can be done with a relay. But when the complication level increases, when the number of inputs and the number of outputs is getting increased and the relation between different inputs and outputs are linked and the complication level increases, it is very difficult to do the wiring and design for automation using mechanical relays. And especially when you have applications like when you need to count and when you need to have a timing and so many other features, it is very difficult to achieve with the mechanical relays. So for a complicated automatic systems or the industrial automatic systems, so we need a controller which can perform this task repeatedly and without error, and which can reduce the time and which can reduce the human interventions. Okay, so for this is the objective of bringing the PLC, and the PLC revolutionized the way industrial processes are controlled. They have enabled the automation of complex tasks, improved efficiency and reduced cost. So now you may see the conveyor control system in any manufacturing industries. You may have seen many hundreds of thousands of sensors being connected in one conveyor system in the process, and all these sensors are connected to a single PLC, and the PLC monitors all these sensors, and based upon the logic written in the program, so this PLC is going to take decision when what action to be done. This is one simple example. Like this we have many applications for PLCs. Almost we can say without a PLC now industry, any manufacturing industry is bit difficult. So now let us see what is IIoT. IIoT is a driving force behind a smart factory concept. So this word is a very important word, smart factory concept. Smart means it has to take decision by itself. Yeah, like telephone, we used a telephone and small mobile phones. Now we have a smartphones. Likewise, the factory without any automation, purely with human and mechanical systems. Later we had semi-automatic or partially automated using relay logics, and later we had the automation without any smartness. So whatever we program it, accordingly the machine performs. But now the next level, the machine has to perform smartly. So that is the new concept, smart factory concept, where machinery and equipment can improve process through automation and self-optimization. So the process itself has to optimize its behavior. So that is the purpose of having the IIoT. IIoT sensors capture data on machine performances, environmental condition and product quality in real time. So these sensors which we are using in IIoT, the purpose of this is to measure various parameters to measure the machine performance and the environmental condition, temperature, humidity kind of things, and product quality. Okay, so different products will have different parameters to be checked. So product quality in real time. So these are the data which we will be collecting from these sensors, and these data can be used for analyzing and optimizing the operation, predict equipment failures in advance, and automate quality control, leading to increased productivity and reduced downtime. So this is the purpose of having IIoT. So here you can see a small picture which shows this IIoT. Almost all the devices or all the equipments, all the machineries in the industry is linked with this IIoT with the different sensors, which is getting connected to a server, and the server is connected to the cloud system, and it can be remotely watched and also can be controlled. So this is one simple example for IIoT. Smart manufacturing, private and public mobile networks. This is an example. So we have DG-IX40. This is a controller, so which is used as a IIoT controller, and we are going to have a different equipments and the process in the industry. So we have the industrial automation controls, condition based monitoring, predictive maintenance, manufacturing process automation, advanced robotics, precision monitoring and control, automated guided vehicles, security cameras, machines like robots and things like that, production digital signage, and all these devices are getting connected to this DG controller, and this DG controller is connected to the network through the Wi-Fi or the wireless communication, and from there it goes to the operation center, and from the operation center it goes to the internet, and from there it goes to the cloud apps, and from there it goes to the DG remote manager. From there you can get the data for 1 year, 2 year, 3 years, or whatever the number of years you want to take the data, you can take the data. A remote network administrator, cloud compute, analytics, cloud based services. So these all possible, and from the internet also locally you can communicate as well here. So we have public, and we can also have a private data. So these devices can be controlled, monitored from a remote place, and also you can collect the data for each and every machine in the industry, and all these data are available in the remote center where you have operation center, and these data, through these data you can predict the machine life, and you can check the quality of the product, and you can check the you can guide the automated guided vehicle, or you can check what is the process going on in that particular sector, and so many things. You can in a room you can sit and you can watch different things, and also you can give a control signals to control from the remote place. So this is also possible, and the main advantages of this IIoT is that the data which is being collected from various sensors at the various stages are used for optimizing the operation, and also it is used for preventive maintenance of the equipments and the quality control and things like that. So this is an example of IIoT. So now let us understand the difference between PLC and IIoT in a detailed way. So I am going to discuss 5 different points to differentiate them or understand them. First one, functionality; the second one, architecture; then integration, cost, and case studies. So these are the 5 different points. Let us see first one, functionality. PLCs are intended to perform control tasks such as regulating a motor speed or controlling machine temperature. So if you take a simple PLC, you take a machine where you want to cut iron piece, or you want to press certain material, or you want to roll some material, or anything, any automation. So based on the requirement you are going to have the sensors, and this sensors is going to measure or sense the objects based on these inputs, and also based on the code what you have written. So this PLC is going to do the control task repeatedly again and again and again and again. So deterministic way. So we are having the predefined instructions, so it is going to do the same work again and again. So the quality of the work and then the repeatability of the work is very high here, and the security and the safety of this operation is also very much ensured. But the IIoT is not for this kind of control purpose, but rather it is used to collect data. So like see, first gather the data, transmit and analyze the data from various sensors and machines in real time. So in any, say for example you take power system, you transmit the power from one place to another place. So we need to know how much power loss is taken place, and in which area how much power is being consumed, and what kind of fault is happened in any place, how much is the temperature morning, afternoon, and power factors how it is varying. So these all different data these are not controlling process, but these are data which is being collected. So based on that we can do many things. When you have a data, you can do anything with respect to the data. So this is the work of this IIoT. They analyze data using advanced analytics and machine learning algorithm to provide insight into the performance of industrial operations. So this is the difference between the PLC and IIoT. So there is a process, that process how it is happening, and what are the mm, data, we can collect it so that to improvise the particular process. So we can collect the data and analyze the data so that we can improvise the things, but the operation is happening there already. Either it can be controlled by PLC or any other controllers as well. Architectures. PLCs are self-contained devices that are programmed with specialized software. Self-contained means if you have a controller and it has its input, output, and then we have the programming device. Whenever we need a program to be uploaded, we connect to the PLC. So the programming device can communicate to this PLC and the program is transferred to the PLC. So these inputs and outputs are being read continuously by the PLC, and based on the instruction the outputs are being controlled. So there is no link between one PLC to the another PLC or one machine to the another PLC or another machine, and it doesn't communicate much. So until otherwise it is a specialized need is there, otherwise it don't communicate. So these are self-contained devices, or it is not connected to a remote place where you can access from there. So they have a collection of fixed inputs and outputs and can be connected to a variety sensors and actuators. They are intended to operate in a closed loop system and they do not require any internet access for the regular operations. In some cases maybe you have communication between one PLC to another PLC, like master PLC and then slave PLCs, or we may have a DCS or SCADA or something like that, but mostly the PLCs works standalone with inputs and outputs. But IIoT on the other hand are networked device. It is a networked device that interact with one another via various protocols such as MQTT, COAP or HTTP. They are intended to operate in an open loop system and must be connected to the internet in order to communicate with cloud-based application. So the purpose of this IIoT is to first to gather and also to transmit the data to a network or a cloud, so that this data can be analyzed in real time or in the timely based. So it has to be communicated, it has to be connected together. So all the devices are connected in a common network, so that the sensors get the information from different devices, so that all the data are being collected to the cloud server or to the real time servers. So from there it is being analyzed. Case studies. PLCs are widely used in manufacturing, automotive and other industrial uses that demand deterministic control. So this is very important, deterministic control. So that means we have already decided what kind of work it is going to do. So once it is designed for that particular task, so that task will be continuously or regularly done again and again until any modification is needed. They are perfect for high reliability and safety critical applications. IIoT devices are widely used in predictive maintenance, energy management and other uses that necessitate data analytics and machine learning. Data analytics and machine learning. Say for example you have a you have a machine, you want to know how much product is being produced and how many products are being defective and how many product is in good condition, and what is the cost of this defective product, or what is the cause for the problems. So you want to analyze that particular machine in detail. So you are going to collect different parameters for that particular machine. So by analyzing these different parameters from the different sensors, you can learn or you can understand why the defective products are being produced and what could be the solution to solve this particular problem. So this is the purpose of having the IIoT. So the predictive maintenance also is going to say how much wear and tear is happening in the tool, or wear and tear is happening in that particular equipment, so that we can have a predictive maintenance. They are perfect for industrial operation that require real-time monitoring. It is, as I told you little earlier, as an example, power system. So real-time monitoring, you need to monitor them continuously, all the parameters, and optimization. So you have to optimize each and every time you have to optimize. Say for example, this optimization, one small example I shall tell you. MPPT, in a renewable energy system we may hear about MPPT system, that is maximum power point tracking, maximum power point tracking. So we have voltage and current parameters, so we should know which is the optimal voltage and which is the optimal current to get a maximum power from the available solar input. So this is called optimization. So for doing this we need to continuously monitor the input from the solar, and also we have to analyze the input parameters like current and voltage, and we have to go through this algorithm, and we have to check which maximum voltage and which maximum current is the optimal value, so that we achieve the maximum power from the given sunlight. So this is one type of real-time monitoring. So similarly in industry many type of real-time monitoring may be happening, and the optimization can be done using this real-time monitoring. Integrations, PLCs have the Modbus communication, OPC communication, UA and MQTT interface can be used to connect a PLC and IIoT devices. PLC can now interact with cloud-based services and use advanced analytic and machine learning algorithms. The recent PLCs have these capabilities. IIoT gateways or edge computing devices can also be used to connect IIoT devices with a legacy system, so that is like a PLC or any other control system. This enables legacy systems to reap the advantage of IIoT without completely overhauling the existing infrastructure. So without changing the existing infrastructure like a PLC based control system or any other controller based control system, so we can connect this old system with IIoT with the help of this gateway or edge computing devices, so that without fully changing the existing systems, we can also incorporate the IIoT to the existing systems, so that we can achieve the better results. Cost wise, PLCs are typically less expensive than IIoT device because they are intended for a specific set of tasks that do not necessitate advanced analytic or machine learning. IIoT devices on the other hand are more costly due to need for advanced sensors, networking protocols and computing powers. How PLCs and IIoT are making the industrial automation more effective. So it increases the efficiency and productivity. As I told you earlier, we had a man-based production system. Later we had a partially automated industrial system, and later we had almost 80 to 90% fully automated system, but without any smartness. And later we have now the intelligence also being introduced into it. So the efficiency and productivity increased when we had a automation system which has the less human intervention, so that the quality increased, the productivity increased, the time this one is reduced, time for production is reduced, and safety is increased. So many ways it is helpful to achieve the efficiency and productivity. Increased security, predictive maintenance is very well achieved with the help of IIoT. Monitoring and optimization in real time, remote monitoring and control is possible with IIoT. Comparing PLC and IIoT benefits and limitations. So it is all summary of what we discussed until now. So PLCs are intended to execute a set of predefined instructions in a deterministic way, allowing for precise control of industrial process. Again and again, I told you this many times, it is a deterministic way of controlling a certain process. So it is a predefined instructions. We are going to give the PLC ladder logic based on the inputs and outputs and the logic what you need to achieve that particular task. PLCs are intended to be highly reliable and to work in a harsh industrial environment. So this can sustain high temperature or high humidity or very high harsh industrial conditions. PLCs have minimal latency and can respond to event in real time. So it is very quick in response. PLCs are programmed using ladder logic or related programming languages that are simple to learn and use. Mostly they use ladder logic or sequential flowchart or block diagram based like that, instruction sets like that. We have different programming methods for PLC. So most widely used or common one is a ladder logic, and also we have other programming tools. Low cost, as we discussed earlier, because PLCs are intended for a specific set of tasks and do not require any advanced analytic or machine learning capability. They are usually less expensive than IIoT devices. Limitations: PLCs have limited data processing capability and are unable to conduct advanced analytic or machine learning, because the purpose of PLC is not to have any machine learning or advanced analytics. So the purpose of having a PLC is to make a process in an automated way. PLCs are intended to operate in a closed loop system and do not require internet connectivity. PLCs are usually standalone device intended for a specific set of tasks, which limits scalability in large industrial environments. IoT benefits: we can have a real-time monitoring, predictive maintenance, remote monitoring and control, advanced analytics and machine learning. So this is going to be the future of any industrial automation. So we must have the data to analyze the process so that each and every parameters can be optimized and we get a better results and we get a better outputs. Limitations: cost, of course it is a costlier one. Complexity: so a normal man may not be having the awareness of IIoT and things like that, so we need a good amount of knowledge about it, because IIoT devices require a variety of communication protocols and networking technologies. They can be difficult to set up and manage. Security: IIoT devices are susceptible to cyber attacks since it is connected to internet. So if you don't have proper security systems or protocol systems, it may be hacked by the hackers, and which may lead to a problem. The future of industrial automation: integrating PLC and IIoT. So two distinct technologies evolved in different time period and used and being successful until now. Even until now, the PLCs are the backbone of any process industry or the manufacturing industry. But the IIoT gives further more wings for the PLC so that it can fly higher. So that is the advantages of integrating the PLC and IIoT. So we integrate the IIoT to the PLC so that it gets a lot of additional features. It can analyze the data, so it is performing the control task. Now from the control task we get different inputs from the sensors. By collecting these different inputs, we can know what is happening exactly in the process so that we can optimize the process. So this is the future of industrial automation. So in future the PLCs will have the IIoT capabilities. That means the advanced sensors all will be connected to the PLCs, and these PLCs will be connected to the server, and from the server all the data will be collected and analyzed, so the process can be automated. Also it can be optimized to get a better results. So that is the future of industrial automation. Thank you. I hope I have given insight about what is PLC and what is IIoT and difference and similarity between them. And in the upcoming videos we are going to discuss a few more topics related to the same thing. Thank you very much for patience listening.